Good morning, everyone. All right, so we're going to work on constant of proportionality. So right here is the phrase we're referring to, constant of proportionality. Definition, the constant value of the ratio of y to x. The ratio of y to x. So we've been talking about ratios for a long time. So the ratio of 5 dogs to 3 cats would be 5 to 3. In math, A, B, and C are very common variables. So we're not going to use A, B, or C for constant of proportionality. So in order to represent the constant of proportionality, we don't want to use a C, so we actually use the letter K. So from now forward, anytime in math class that you see the letter K, that is going to represent the constant of proportionality. If you look right here, this is the formula that we're going to use to calculate the constant of proportionality. The constant is equal to the ratio of y to x. So what we're going to do is we're going to take a look at our table, and we're going to calculate the ratio of y to x. So it says if k is the same for all of the values of the table, then that is your constant. But if the constant is not the same, then we're just going to put none because it does not remain proportional. All right, so if we're thinking about the ratio of y to x, so the ratio of y to x, and I'm going to look at my very first pair of numbers here. So the y value goes on the top, so y is 12 and x equals 3. So the ratio of that would be 4. If I look at my next pair, y to x, my y is 16 and my x is 4, and that simplifies to 4. If I look at my next values, the ratio of y to x, my y is 20 and my x is 5, and that simplifies to 4. And if I look at my last one, I've got 24 for y divided by 6 for x, and that simplifies to 4. So because all of my ratios simplified to 4, your answer, let me choose a different color, your answer would say k equals 4. The constant of proportionality equals 4 for table 1. All right, so I'm going to focus over here on table number 2. So we do y divided by x. So that's 10 divided by 2 simplifies to 5. And then y to x would be 15 divided by 3 equals 5. Then I have 19 divided by 4. That looks a little funky. I know 19 divided by 4 does not equal 5. So because I found one that is not the same, your answer would say k equals none. There is no, I don't know why that's not writing. There is no constant. Oh my goodness, what's wrong with my pen here? Sorry about that. So your answer would say k equals none. Constant of proportionality equals none, since they did not all simplify to the same. All right, so let's look over here at number 3. So now this one can look a little bit different. Be careful because the y values are on the bottom, but when we solve, the y goes on the top. So watch what I'm going to do here. I'm going to have 2 to 3 for the first one, and then I've got 4 to 6 for the second, 6 to 9, and 8 to 12. Now, one other way that you can also tell constant of proportionality, if the numerator is smaller than the denominator, one easy way to do this is to simplify. So look at 4 to 6. If I'm looking at this and I simplify that, I would divide by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So I've got 2 to 3 for the first column. My second column simplifies to 2 to 3. If I look at 6 to 9, 6 divided by 3 is 2, and 9 divided by 3 is 3. So that simplifies to 2 to 3. And if I look at 8 to 12, if I divide 8 by 4, I get 2. And I divide 12 by 4, I get 3. So that answer would be K equals 2 to 3. Your constant of proportionality equals 2 to 3. Okay, so we've got one more page. So instead of a chart, you can also show constant of proportionality by graphing to find out if a if a relationship has direct variation. Having direct variation is the same as being proportional. So we've talked a lot in the last couple of weeks about proportional. We've used cross products, we've used a common multiplier, we've reduced both ratios to see if they reduce to the same ratio to be proportional. So having direct variation is the same thing as two ratios being proportional. All right, so use the formula that you used before. So I'm going to find my 3 points. If I look at, so I'm looking from the bottom of the graph up. So I'm going to focus on this point that I'm highlighting in yellow down here. So remember, the relationship is y to x. So if I'm thinking constant is y to x, that very first point has a y value of 3 and an x value of 1. So that's my first point. If I go to my second point that I'm highlighting now in yellow above that, my y is 6. Whoopsies. Sorry. And my x is 2. Oh, but look at that. That would reduce to 3 to 1. If I look at my last point way up here at the top, my y value is 12. Oh my goodness, I did it again. And my x value is a 4. Well, 12 to 4 also simplifies to 3 to 1. So that would be a constant of 3. K equals 3 is how you would write that answer. There is a shortcut. If the graph is a straight line, remember this. This is a really, really quick tool for you to remember. If the graph is a straight line and it passes through 0, 0, which is your origin. I'm going to highlight your origin down here, and I'm going to highlight your origin down here on number 5. It automatically has direct variation. Okay, let's read that again. There is a shortcut. If you look at the graph and the line on your graph is a straight line, and the line also passes through points 0, 0 at your origin, it automatically has direct variation. So then you don't have to do any math. You can just visually look at your graph and say, yes, it has direct variation. So this can be mental math. So let's look at number 4. Do we have a straight line? Yes. Does it pass through points 0, 0? Yes. So yes, it has direct variation. Why? You would write, it is a straight line. I clearly need a new stylus that's going to write near to this. And it goes through points 0, 0. If you look at number 5, that's an automatic no, right? It's a straight line, but it does not pass through 0, 0. 0, 0, no. All right, last thing. To summarize, the constant of proportionality is a ratio. Once again, the formula that we're going to use, the constant is equal to the ratio of y to x. Having direct variation is the same thing as being proportional.